Hello 8th graders, today we meet again in online learning SMPK Penabur. I hope all of us and all of our family still in a good condition. After we have learned about vibration, now we will learn about factors that influence period of pendulum and spring. Basic competence for our topic today is 3.11. To analyze the concept of vibration, wave and sound in our daily life, including human hearing system and sonar in animals. And 4.11, giving data from the result of experiment about vibration, wave, and sound. To understand about factors influence period of pendulum, firstly we will see the simulation of pendulum. Let's see the simulation. In the simulation, to determine period of pendulum, we don't need to count the number of vibration and see the stopwatch time needed to the number of vibration. In here, we just need to press the button of period. For the length of pendulum 0.8 meter and mass of the load 1 kilogram at gravity 10 meter per second square, we get the period is 1.78 second. And if the length of pendulum become 1 meter and the mass still 1 kilogram at gravity 10 meter per second square, we get the period is 1.99 second. And if the length of the pendulum still 1 meter and the mass of the load become 1.5 kilogram at gravity 10 meter per second square, the period of pendulum still 1.99 second. Doesn't change. And if the length of pendulum still 1 meter and mass of the load still 1.5 kilogram at gravity 9 meter per second square, the period of pendulum change become 2.0976 second. And if the displacement of pendulum is maximized or changed, we see that the period not change too much. So from the simulation period of pendulum, from the simulation can be concluded that the period of simple harmonic motion on pendulum doesn't influence by magnitude of displacement or mass of per pendulum or mass of the load. Period of pendulum just influenced by two factors. First is length of the rope that gives symbol L, and second is acceleration of gravity that gives symbol G. The relation period, acceleration of gravity, and length of the rope can be formulated with formula T equals 2 pi times square root L per G. Note, L is length of the rope and the unit mass in meter. And G is acceleration of gravity, the unit mass meter per second square or Newton per kilogram. To understand about the problems in factor that influence period of pendulum, let's see the example below. The first example, At the physics laboratory, students make an experiment to measure time vibration of simple pendulum, which has length of the rope 155 cm, and if time needed to 20 vibration is 50 seconds, determine acceleration of gravity at that place. From the problems, given length of the rope L equals 155 cm equals 1.55 meters, and number of vibration N equals 20 and T equals 50 seconds. Ask acceleration of gravity G. Answer: because at the problems there is information about period, but in here there is number of vibration and the time. So we can calculate the period using formula T equals T per N. So the period equals 50 seconds divided by 20 equals 2.5 seconds. And to get the acceleration of gravity, we must use formula T equals 2 times pi times square root L per G. And with the we give square at both sides, we can get the formula become T square equals 2 square times P square times L divided with G. And 2.5 seconds square equals 2 square times 3.14 square times 1.55 meter divided by G. And the result, we can get G equals 9.78 meter per second square. And for the second example, period of pendulum that has rope with length 81 cm in the laboratory is 9 seconds. Determine period of pendulum if length of the rope is made 100 cm. From the problems given, L1 equals 81 cm and L2 equals 100 cm and period 1 equals 9 seconds. Ask period 2. Answer: to get the period 2, we can use ratio formula that T1 per T2 equals 2 pi times square root L1 per G divided by 2 pi times square root L2 per G. And if we square at both sides, we get that T1 square divided by T2 square equals L1 divided by L2. And 9 seconds square divided by T2 square equals 81 cm divided by 100 cm. And we can get that T2 square equals 100 divided by 81 times 81 seconds square. Because of that, T2 square equals 100 seconds square. And then we can get T2 equals 100 seconds. After we have learned factors influence period on pendulum, now we will learn factors influence period on spring. But firstly, we will see the simulation on the spring below. From the figure of simulation, there are two springs which have different spring constant. As you can see, that spring 1 has small spring constant or spring strength, and spring 2 has big spring strength or spring constant. Now we will see the process to determine period on the spring. While spring 1 is hung by load 250 gram for 10 vibration, needed 12.95 seconds. And for spring 2, for 10 vibration 2, spring 2, spring 2 needed 9.30 seconds. And if spring 1 is hung by load which has mass 100 gram for 10 vibration, spring 1 that hang by load 100 gram for 10 vibration needed 8.23 seconds. And for spring 2, while hang by load 100 grams, needed 5.85 seconds. From the simulation, we get data for spring 1 to 10 vibration with load 250 grams needed 12.95 seconds. So period of the spring is 12.95 seconds divided by 10 equals 1.295 seconds. And for spring 2 to 10 vibration with load 250 gram needed 9.30 seconds. So period of the spring is 9.30 seconds divided by 10 equals 0.93 seconds. And for spring 1 to 10 vibration with load 100 grams needed 8.23 seconds. So period of the spring is 8.23 seconds divided by 10 equals 0.823 seconds. And for spring 2 to 10 vibration with load 100 grams needed 5.85 seconds. So period of the spring is 5.85 seconds divided by 10 equals 0.585 seconds. This means, first, the period for two springs which have different spring constant are different for the same number of vibration and same load. And the period for the same spring with the same number of vibration, but different mass of the load are different. So period of the springs. From the simulation, period of simple harmonic motion on the spring just influenced by first mass of the load, which is given by symbol M, and the second spring constant, which is given by symbol K. Relation between period, mass of the load, and spring constant can be formulated with formula T equals 2 pi times square root M divided by K. Note, M is symbol for mass of the load and the unit mass in kilogram, and the K is symbol for spring constant and the unit is Newton per meter or kilogram per second square. To understand about the period of the spring, now let's see the example below. Example 3. Spring with load 100 grams makes simple harmonic motion. If amplitude of vibration 10 cm and frequency of vibration 2 Hz, determine period and value of spring constant. Given M equals 100 gram equals 0.1 kilogram. Amplitude equals 10 centimeter equals 0.1 meter. And the frequency equals 2 Hz as period T and spring constant K. Answer: period equals 1 divided by frequency equals 1 over 2 Hz equals 0.5 seconds. And to determine the spring constant, we must use formula T equals 2 pi times square root M over K. If we square two sides, so we can get T square equals 2 square times P square times M per K. So 0.5 seconds square equals 2 square times 3.14 square times 0.1 kilogram divided by K. So K, the spring constant, is 15.78 Newton per meter. After you have learned about the factor influence period on pendulum and spring, to enhance your skill, now let's try the challenges problems below. A pendulum which has length L meter has period 8 seconds. Determine period of pendulum for the figure below, or time needed to move from A, B, C, B, A. If there's a problem, you can discuss this problem with your teacher. I think that's all our materials today. I hope all of these materials can enhance your skill in period of pendulum and period of the spring. God bless you.